A close-up of Jupiter caught on the Juno mission's 38th orbit around the planet. Thomopoulos /NASA/JPL-Caltech/SwRI/MSSS. As it seeks answers about the cosmos and what they mean for Earth's origins, NASA on Friday announced a slew of discoveries about Jupiter. And scientists brought home an interstellar tune from the road. The Juno spacecraft is gathering data about the origin of the solar system's biggest planet, in which more than 1,300 Earths could fit. Among its recent findings are photos from inside the planet's ring, a map of its magnetic field, details of its atmosphere, and a trippy soundtrack from a spacecraft's travels around one of its moons. But it's not exactly a song, or even perceptible to the human ear. The radio emissions Juno recorded are not what a person would hear if they went to Jupiter. Space is a vacuum and does not carry sound waves like air does on Earth. But the probe zooming through space captured the electric and magnetic emissions that scientists later converted into perceptible sound. Turns out, orbiting Ganymede, which is one of Jupiter's moons and the largest satellite in the solar system, kind of sounds like R2-D2. Juno, which NASA launched in 2011 and began orbiting Jupiter in July 2016, is the 8th spacecraft to visit Jupiter and the first to probe below the giant planet's thick gas cover. It fought Jupiter's extreme temperatures and hazardous radiation to survey its north and south poles, chugging along despite a lack of sunshine on its solar panels. Uncovering the secrets behind Jupiter's workings could shed light on the evolution of other planets and the formation of the solar system itself, said Scott Bolton, the Juno mission's principal investigator. "We're trying to understand where we came from, how we got here," Bolton told the Washington Post. And Jupiter is a big part of that story. To accomplish that objective, the spacecraft has flown across the giant planet, mapping its magnetic field. The mission, which recently completed its 38th orbit, was extended this year to add flybys of Jupiter's moons such as the one in June that led to the Ganymede audio track. The sound, Bolton said, represents an immersive experience into the mission's travels past the moon for the first time in more than 2 decades. Juno also discovered that the planet is being pelted by tiny but powerful particles from Mars. Jupiter's gravity acts like a gate pushing the micrometeorites out of its orbit, similar to how it may have bullied other ancient planets out of the solar system. Scientists are now setting up to detail Jupiter's ring. Much like Saturn and Uranus, the gas giant has a faint ring of dust created by 2 of its moons. The spacecraft already took a look at it from inside the ring, an observation that allowed the researchers to see the Perseus constellation from a different perspective. "What always impresses me is we wind up discovering all kinds of stuff that we never anticipated," said Jack Connernet, Juno's deputy principal investigator. Jupiter is unlike the 8 other planets in our solar system. With the exception of a rocky core, the planet is made of gaseous and liquid elements. Surrounded by electrons, protons and ions that rapidly bounce around, Jupiter's cloud cover has a layer of liquid metallic hydrogen. Its core remains a mystery, but scientists believe a motley of diffused elements that are heavier than helium are at the very center. This configuration paves the way for a dynamo or the source of a magnetic field, Connernet, an astrophysicist at the NASA Goddard Space Flight Center in Greenbelt, Maryland, said. "The result," he said, "are spectacular aurorae, or tremendous depositions of energy. Much like our own northern lights, but thousands of times brighter." With the data generated by Juno, Connernet and his team were able to map Jupiter's magnetic field. Their study also revealed that the dynamo action stems from metallic hydrogen beneath a layer of helium raindrops. This image shows 2 of Jupiter's large rotating storms, captured by Juno's Visible Light Imager on November 29. Kevin M. Gill, /NASA/JPL-Caltech/SwRI/MSSS. The interior of the planet is dynamic as well. It spins every 10 hours and holds raging wind jets that give Jupiter its Van Gogh-like swirls. Within its southern latitudes, the Great Red Spot is essentially a hurricane that has been observed since the age of Galileo. But scientists have found another formidable patch, the Great Blue Spot. "The Great Blue Spot is really a magnetic anomaly," said Connernet. Its name stems not from its color, but from how magnetic field lines are drawn, sporting blue when they go into the planet. It also offers clues about the planet's workings. "We actually detected a big change from the beginning of our Juno mission in 2016 to now," he said. We detected a change in the magnetic field that is equivalent to the eastward drift of the great blue spot in time, very slow, about 4 centimeters per second, but fast enough to circle the planet in about 350 years. The great blue spot is being pulled away by Jupiter's jet streams, a pattern that shows that the planet's winds extend down much deeper than they originally believed. The discovery of the anomaly getting turned around, Bolton, Juno's principal investigator, could shed light into one of the biggest questions scientists are hoping to answer: how does Jupiter's atmosphere work? This is really the first time that we've seen a magnetic field getting affected by the atmosphere, he said. It really demonstrates that its deep atmosphere is very dynamic, much more than people had thought. Uncovering Jupiter's secrets, said Bolton, is a humbling experience, one that can make us feel like tiny specks, but also reminds us of how much there is left to explore. Throughout history, we often thought of ourselves as the center of everything because, in a sense, you're looking out right from your own eyes and your own brain, Bolton said. But there are many things out there.